that's an important learning, that when I cut, whatever I say 1 is, so if I say this is 1, then every other piece of that can be named as a fraction of 1, a part of 1. Right? So if I cut it into 2 parts, then each part is 1 out of the 2 pieces I need, or 1/2 to make the whole. If I cut it into 4 parts, each one is 1 out of the 4 pieces that I need to make the whole. But if all of a sudden I told you that this is a 1/2, not 1, right? Then the names of these pieces change. Because now in order to make the whole, I would need 8 of these little pieces, not 4. And that ability to take the whole and know that the fraction name comes from whatever we call 1 is the most important thing kids can understand about fractions. Okay? They need to know that it depends. And you know what? So does counting. So do whole numbers, right? Whole numbers are all in relation to the unit, which is 1. So if I said, show me 10 pennies, you need to know what 1 penny looks like, because you need to build me 10 of that. If I said, show me 10 widgets, you would say, well, what's a widget? Right? So I might have an idea in my head of something that it is, but unless I tell you what 1 is, then it's hard for you to build what 10 of that is. Right? There's an abstraction about number that we take for granted because we've done so much with it, we kind of begin to just accept it as. But for little kids, build me 10, show me 10, the answer should always be of what? Right? Build me 10 of what? And there's an implied sense. So kids might say, well, I'm going to build you 10 of my cars and show you 10 with my cars, or I'm going to show you 10 with my Cuisenaire rods, or I'm going to show you 10 with my 2-color counters. But it's always in relation to something that we have called 1, even when we're using whole numbers. So fractions are the same. I can't show you a 1/2 until I know what the whole is. I can't show you a 1/4 until I know what the whole is. Thought I turned my email off. Okay? So it's really important that we spend a lot of time in grade 3 and 4 getting kids to model in lots of different ways. So most of these ones I've just shown you are area models, but we also have Cuisenaire rods are interesting. I've given you some of those. We're going to play with them. But the nice thing about Cuisenaire rods is that they are more like proportional models. And in grade 6, we do a lot of work with ratios. So I can build a 1/2. Whoops. I can build a 1/2 as 1/2. And show that I need 2 of the white in order to make 1 of the red, right? So white is 1/2 of red. But I can also show you (3 over 6) is also a 1/2, right? Because I need 2 of the light green to make 1 of the dark green. So Cuisenaire rods are nice for showing kind of a proportional model of fractions. So 1 is to 2 as 3 is to 6. Right? And so we can get kids to use Cuisenaire rods to build models in lots of different ways. And we're going to play around with those a little bit later when we do some addition. Other models that are super important are linear models. Okay? Just like with counting numbers, students need to know their fraction number lines. We did that last year, didn't we? Some of us, we took this strip of paper and folded it in half. Okay? So that sense of having a sense of where fractions are in relation to one another, this shows that a fraction can be a unit of measure or a length, a linear measure. Right? So if I say what is 1/4 plus 2/4, I can think of that as a jump to 1/4 and then a jump 2 more quarters to get to 3/4. Okay? And so we can add fractions on a number line by thinking about it as a linear measure. But you need to be able to think about where fractions are in relation to one another. Okay? And that's why it's important to do a lot of work with number lines. It's especially important when we're comparing fractions. If you look at this little model, you can see that 5/8 is greater than 9/16, right? 5/8 is greater than 9/16. 5/8 is equivalent to 10/16, so it's a little bit more than 9/16. Okay? So by looking at number lines and being able to compare, it's going to make it really useful for you in terms of understanding fractions. Now the strips that you have, you can line those up. And a lot of people, the first thing they do when they open the set is they line them up. And they make a nice number line. I do like them for that. Right? Kelly, do you have a question?
I was just going to ask, what grade would you introduce the number, like the fraction number? I've never seen a fraction number line used in a classroom ever.
Yeah, I know.
Maybe that's because I'm not in the right grades.
Yeah. In the new curriculum, it will be introduced in grade 3. Okay. In the new curriculum, it will be introduced in grade 3 that we will do area models, set models, and linear models. So although you're not doing anything like operations or anything like that with fractions, you are going to spend a lot of time just talking about the different ways we use fractions in the world. So we use it as part of an area, part of a set, or part of a link. And so we'll do a little bit of number line work, probably some paper folding, probably some lining up of strips or cutting strips. On the Blackline Master site, there's a nice fraction. Let me see, I think I have Blackline Masters here. There's a nice little fraction strip that you can get. I think I linked these from your Move site, but I have them all downloaded on my laptop too. This one? Yeah. So they have these nice, what they call fraction lines. And so you can see all the relationships between the fractions, so we can get kids to build them. But currently, this should be being done in grade 4 and probably 5 and 6 when we're talking about equivalence, because it's such a nice way to model equivalent fractions. Because you know, you line it up and you see, you know, who's equivalent. Well, I see a half, 2/4, 3/6, 4/8, 5/10, 6/12. Those are all equal, right? They're equivalent. And I see 3/4, 6/8, 9/12 equivalent, right? So it is a nice way to model equivalent fractions, but it's the same thing. I think you'll remember in elementary we talked about the fact that kids don't seem to have enough experience with number lines, and about the fact that they're really not very obvious in the curriculum document, right? There's not a lot of emphasis on using a number line in the curriculum document, and I think it gets overlooked. People kind of go to the concrete models, which is great for fractions. It's probably the one thing where people are actually willing to use the manipulatives, right? Even those who were resistant will pull out the fraction manipulatives because it helps. But the number lines often get overlooked, but they're really, really useful, and they actually are really helpful in operations in addition to subtraction for sure. So it is nice to be able to expose kids to that if we can. And then the other one that we often use is a set model. So I could say 2/5 of this fraction are yellow. Okay? And in grade 6 we start doing ratios. Okay? So for ratios, and we'll talk more about ratios later on in this course, but just as a sort of brief introduction, I could write this as a part to whole ratio. So 2 out of 5 are yellow, right? Or I could write it as a part to part ratio. For every 2 yellow, there are 3 red. Okay? And so then if I wanted to find an equivalent ratio, In this case, I'm actually increasing the size of my total set, right? So now I'm saying, still for every 2 yellow there are 3 red, but I can also see for 4 yellow there are 6 red. And I've shown that this is an equivalent ratio.
Using like a template with those, is that sort of like with the, I didn't teach primary math, but the teachers that did it used templates on me, use like the red and yellow, and he'd say that in the primaries, can you put half them red and
Yeah.
half them yellow?
Because in primary right now we do have an outcome that says understanding the meaning of half in context. And so we would say, you know, make them half yellow and make them half red. And so you're working on the notion of, really, that's building into the notion of partitioning, like breaking a number into 2 equal parts. So if I take 6 and I do half yellow and half red, then I've got 3 and 3 makes 6. And I'm partitioning it and I'm working on my doubles, right? So later I'm going to have to remember that 3 plus 3 is 6. So when I do 6 and I've made half of them yellow and I know that that's 3, that's helping to build that.
Okay.
But it's also laying the groundwork for that sort of proportional reasoning later on. So, yeah. Now, that's an interesting point because right now in primary 1 and 2, we have fraction outcomes in our current curriculum. In the new curriculum that's coming down, or if you're teaching anywhere but Nova Scotia, you won't. Okay? Because all of the other provinces, with the exception of Ontario and Quebec, have gone to the Western Protocol. And the Western Protocol introduces fractions in grade 3.
So they don't know how to make a half until grade 3,
Technically. It's not that they won't know how to make it, it's that they won't be expected to have that as sort of a math outcome until grade 3. It's likely that we'll say, oh, can you give me half of that file? Or we'll do things like what Megan was talking about, partitioning. Like, is there a way I can take 6 and break it into 2 equal piles? Right? Because we do, it's fractions, but it's also division and it's also partitioning. We're just not calling it fractions and talking about it as a fraction until grade 3.
So they're doing the same thing, they're just calling it by a different name.
Sort of, but there's not that same expectation that the kids would know the word half. We might use it informally. We wouldn't assess them on whether or not they can use it.
So they're not going to be doing.
Well, it is a different expectation. Before, we had teachers doing all kinds of activities with kids, building a half, cutting things in half, all that kind of stuff. Which is
Share.
Yeah, we're still going to share, which is really more about leading up to division, but we're not going to expect them to have that fractional language down. Or we introduced the symbols before in grade 2. Yeah.
He also did like, you know, like those little ones pieces. So we'd get them, put like a polyspot on the ground. They'd have to count out 10 on each polyspot like around the class, and
Yeah.
then they would trade it for like a 10.
Oh, good.
Is that like for the primary? Is that?
That's way advanced for primary. That would be grade 1, A11. Our current curriculum. That's
Will that be taken out of the curriculum too then? Like stuff like, I guess is that sort of building on the idea that there are 10 little pieces in one that has 10?
There's actually a big emphasis in the new curriculum on understanding numbers to 10 in grade primary. So something like that where you're actually saying, you know, building 10 in all kinds of different ways would actually be more emphasized. In fact, spending more time doing that rather than less. The big idea with this shift in curriculum and not having any of that kind of fractional sense in the P1-2 is to really solidify whole number by the end of grade 3.